Kirti, shall we start?
We may start. Uh,
A warm good afternoon to one and all present here. So, we are doing our career guidance session one by one, and each session turned out to be a gem of a sessions. So, we are expecting the same here. And I can see that participants' number is slightly less, but I think they'll join us. So, without any further ado, let's welcome our resource person for the day. So, I from everyone present here, I extend my warm welcome to you, sir. So, about our resource person today, he is Mr. Abhishek Seth, and he is currently working as the assistant director at Aakash Educational Services Limited, and he has done his BTech from IIT Delhi. So, we welcome you, sir. The stage is yours, and everybody, please give him a warm welcome.
Thank you, ma'am. Thank you so much. I would like to, first of all, welcome all the kids here who are going to appear for their JE in a couple of days from now. Ma'am, is the screen sharing allowed?
Yeah, yeah.
I'm getting the message that host has disabled participant screen sharing.
No, we'll enable it, sir.
So I'm sure all of you would have prepared well by now, and you'd be feeling a little nervous also at times, a little jittery, but really, thank you. Now it's enabled. So really, it's not, it's not going to be that difficult if you follow a right strategy. I mean, one of the things that we normally do wrong is like we try to do as many questions as possible. We also try to, attempt questions. Uh, just a minute, ma'am. Is the PPT visible to all?
Yeah, sir.
Yeah. So we normally try to do questions which we think in topics that we are comfortable with, and that should be the normal strategy. But what has happened in couple of last years is that papers have been such that mathematics has been a little lengthier section, and therefore because of that, students have those, particularly those students who are really very comfortable with mathematics, even they found the question papers very lengthy. And despite having an expertise in mathematics, they got stuck in one or two questions which dragged their time and then overall performance decreased. So even though I'm here to guide you about mathematics, I would like you to tell you at the very beginning that you must select your questions wisely in the examination paper, because it's true that you might be able to do the question, and I'm sure you would be able to do the question. But if the question is lengthy, it's taking much more time, it's better to move on to another question, because number of marks are same. Anyways, so the first, the flow of the presentation would be like it has been in the previous, presentation for physics. I would be covering, first of all, the important topics. We will be looking at high and medium priority topics first. And this is based upon the frequency of questions which have been asked in JEE Mains 2019 to 2023 data. You will see that some of the topics have been deleted also. So we need to, actually after that, follow it up with the substantial changes which NTA has done. Okay. And then followed by some of the questions I'll be taking from past 2 years only, 2023 predominantly, and then some couple of questions from 2022. So that you can see the kind of questions they've been asking and what are the kind of tricks that you probably may employ there. So let me first take you through the list of important topics first, okay, without wasting any time. If you look at these chapters, I'm sure you would have seen it earlier. The green topics are the ones which are important, and the red ones are also important, but they have a medium frequency. So what I have here is, like you can see here, it's green topics which are high priority topics, and medium are the red ones. Okay. So set theory, probably the operations on sets, they are important, predominantly important. Then some practical problems on union and intersection of two sets. Okay, that would include also principle of inclusion exclusion. Uh, with respect to operations, I think symmetric difference is something that you must pay attention to. Some problems on combinatorics overlapping with set theory are also to be expected. Okay, trigonometric functions. It has been seen in the past, 4 5 years. Trigonometric equations, height and distances. Okay, height and distance has been eliminated, as we'll see. So even though some of the topics mentioned here have been eliminated, we'll cover that in the next data that we'll see. Property of triangles, transformation formulas, they have been very important in the past, followed up by trigonometric functions and trigonometric ratios of multiple angles. Complex numbers, uh, different particulars of complex numbers. So the real part, imaginary part, equality of complex numbers. They are the kind of topics that are important. Argument, properties of argument, and then circle in Argand plane. And when I talk about circle in Argand plane, basically they are trying to say here unimodular numbers, numbers which have modulus equal to 1. They have been very, very important. You will see many questions, very high frequency of questions coming on that. So if Z is a unimodular number, north, conclusions follow out of that. That is important. And then cube roots of unity. Okay. Then other topics which have also been important are different forms of complex numbers, geometry of complex numbers, algebra of complex numbers, and then important loci. So that will be like equation of ellipse hyperbola in terms of complex number. With respect to quadratic equations, you'll see the property of nature of roots related to nature of roots. Nature of roots, when I say, it's not just real roots, distinct roots, it's also integral roots. They're also very important. So if it has been given to you in a question, and normally people don't even look at the data correctly, so you must look at the data, and one of the clue, if it is given to you that an equation has integer roots, or somewhere it has been mentioned that certain parameter is an integer, that could itself play a role, because integers have special properties. They are properties related to divisibility, which are very important, and therefore that must also be taken as a clue in a question. In sequence series, it has been seen arithmetic progression, geometric progression, special series. Special series has been deleted actually. Okay, special series has been deleted. Arithmetic mean, geometric mean, inequality, telescopic sums, and then AGP has also been deleted. So even though it is mentioned here, it has a deleted topic. Permutation combination, then here you actually look at permutations under certain restricted conditions. So they will impose certain conditions, like certain items can come together, they can't come together, or if two things are some sort of conditions are put there. Special uses of NCR numbers, divisible by 2, 3, 4, 5, 7. So divisibility rules might play a little role in combination with permutation combination. It'll be good advice to go just through the divisibility properties, and then the fundamental principles of counting. So okay. So binomial theorem, again, properties of binomial coefficients has been eliminated. I think this was one area which students usually find because they have very vast number of properties when you come to binomial number of binomial coefficients. So these properties have been deleted. Problems based on general expression, particularly the middle term, and there are certain questions related to term independent of x or the variables, right? Those are the kind of problems which are important. Multinomial coefficients occasionally, and then some special forms of binomial theorem. Okay. Straight lines, different forms of straight lines. The equations, different forms. There are about approximately 8 forms, which are important. Analysis of two lines, different centers of triangle. Okay, orthocenter, circumcenter. Okay. Then image reflection, foot of perpendicular, perpendicular distance of a point with respect to line. These are all very important topics. Conic sections, one, when we say conic sections, one, we basically mean circle. So circle is itself very important. Analysis of two circles and then family of circles. In conic section, parabola, ellipse, hyperbola have all been very favorite. But as you'll see, this year they have deleted equation of tangent, which would mean, therefore, eccentricity would play, I think, quite a bit of role there. Latest vector, all the essential things which NCRT mentions, they'll frame questions around those things, okay? Mathematical reasoning has been deleted. I'll not go there. Limits and derivative. So finding the limits. And then even when you talk about limits, you would have seen questions where either they, you know, uh, give certain parameters and they ask if the limit exists and it is non-zero, then you have to find the value of those parameters. So basically those kind of questions have been, if I remember, I gave JEE in 1996. And since then I've seen every year there's one or another question based on those kind of, tricks. Statistics, variance and standard deviation are extremely important. Relations and functions, all the elementary functions that we study, GF, fractional part especially. Then the replacement property of function, okay, that is also important. And then relations. When I say relations, I'm talking about topics that we covered in 12th, particularly binary relations and associated kind of binary relations that we are talking about. They're important, okay. Inverse trigonometric functions, then sum and difference formulas, and the domain and range of basic inverse trigonometric functions is important. Sometimes you'll see occasionally in solving inverse trigonometric equations, and then conversion of one inverse function into another. Matrices is quite a bit of important because you see matrices and determinants are something, they're the tools of basically all the mathematics, higher mathematics that we do, especially engineers do. So I think that is going to be very important again this year. They have deleted a solution of homogeneous equations. So that is one part you might not need to pay attention. But other than that, and then properties of determinants have also been deleted. But other than that, adjoint of matrix, product of matrix, matrix polynomials, operations of matrix, symmetric and skew symmetric matrix, they're all extremely important. Okay, you have to prepare that very well, and it's easily scoreable also. It's not difficult. Continuity and differentiability, limit, continuity, differentiability, differentiation, mean value theorem have been deleted. They were important, but they have been deleted. Applications of derivative, maximum minima, increasing, decreasing functions, tangent normal, rate of change. All important. Integration, again, very important. And then when you come to area of under boundary between the curves, again, it is important because see all these topics of 12th, which fall in the later half in the book part 2, they are extremely important. They are important because they will be used. All these topics are primarily used by engineers. So we have to pay attention to those topics, okay? Differential equations, method of solution of ordinary differential equation of first order and first degree, geometrical and physical applications. Okay, I think formation of differential equation has been deleted. We'll just go through that. If I remember correctly, it has been deleted. Vector algebra, product of vectors, solving vector equations. They are important. Scalar to product has been deleted as we'll see in the next slide. 3D geometry, plane has been important, but we'll see. I think some part of it has been deleted. Point in plane, equation of line in space, line in plane, family of plane, shortest distance between two lines. Shortest distance between two lines was asked too many times in the last year. Kind of important. Probability, computation of probability of events using permutation combination, random variable. Bernoulli tree and binomial distribution has been deleted. Conditional probability is therefore now doubly important. It was important earlier also. J advanced and J mains both basically like to give questions from that topic, and then definition of probability itself. So what are also important are independent events, definition of that, addition, rule of probability, and Bayes theorem. Okay. So I have briefly covered, all the topics that have been high priority. And now go through the list of topics which have been deleted. Okay. So we'll go chapter wise and see what has been deleted. If I look at mathematics class 11th, basics of mathematics, nothing has been deleted. Relations and functions, nothing has been deleted. Trigonometric functions, heights and distances has been deleted. So you need not worry about that. Principle of mathematical induction, not deleted. Quadratic equations, nothing has been deleted. Complex numbers, square root of a complex number, and triangle inequality has also been deleted. Okay. Square root, when I say square root of a complex number, actually, this is like uh, because cube root has not been deleted, right? So if you go through, so there are two ways in which you can find nth root of unity. Uh, when you say nth root of unity, you can also talk about square root also. So using Euler form, if you were finding a root that is covered, but this is another method which we use using Cartesian form that has been deleted. Linear inequalities has been no change has been made. Sequence series, you see, sum of n terms of a special series has been deleted. Then powers, sum of powers of n, like sum of when n is a natural number. So sum of first n natural numbers, sum of squares of natural numbers, sum of cubes of natural numbers, problems on those have been deleted. And then arithmetical geometric progression has also been deleted. Okay. So permutation combination, there has been no change whatsoever. Binomial theorem, you see properties of binomial coefficients has been deleted. Uh, so basically, what is left then, therefore, is like the questions based on divisibility, questions based on finding the particular term, eighth term. Then there are certain questions where we ask about finding GF of a certain expansion, greatest integer function of so those kind of questions are all there. Okay, term independent of x or a variable, sum of coefficients maybe that can be included, because even though it's covered in the property of binomial coefficient, it could be also seen as substitution of particular value in the binomial theorem also. When you talk about straight line, translation of axis, so shifting, and then I think when they are saying translation, they also mean to say rotation of axis is also not covered now. Equation of internal and external bisectors. Okay, the spelling here is incorrect. So BI, bisectors of angles between two lines. Equation of family of lines passing through the point of intersection of two lines. So when I say that, I mean to refer when you use that form L1 plus lambda L2. So family of equations, family of lines, straight lines, that is also has been deleted. Okay, so when then we go to conic sections, we see condition for a line to be a tangent to a circle. So condition of tangency, like for circle, we have c square is equal to r square into m square minus 1. That has been deleted. Questions based on that has been deleted. And again, finding the point of tangency. So that has also been deleted. It's a very small deletion. Other than that, most of the things are deleted, already included. 3D geometry, no change. This is 11th syllabus. We'll come to 12th. Again, 3D is repeated there. Limits and derivative, no change. Math and reasoning has been deleted, overall. Statistics, no change. Probability, no change in standard 11th syllabus. Relation functions, all of it is included. Inverse trigonometric functions, no deletion. Matrices, elementary transformations, elementary row, transformations have been deleted. Determinants, properties of determinants, and then solution of simultaneous linear equation in 2 or 3 variables using determinants has been included. That means Cramer's rule has been deleted. Okay. Continuity and differentiability, Rolle's and Lagrange's mean value theorem, they have been deleted. Other than that, all of the syllabus there. Applications of derivative, tangent and normal have been deleted. Definite integrals, integral as a limit of a sum. So those questions where you have limit and then you have a summation and tending to infinity. And then finally you convert that question of limit into an integral has been deleted from J main syllabus, right? Applications of integral, there has been no change. Differential equations, the formation of differential equation, wherein you're given a family of curves and then you're supposed to, it's a very small relation. in my opinion. And the questions, anyways, from this topic were relatively very simple. So they have been deleted. Vector algebra, scalar and vector triple product has been deleted. Okay, other than that, cross product, dot product are already there. So triple products have been deleted. Three-dimensional geometry, a plane in different forms and the intersection of a line in a plane, and then coplanar lines. So coplanar, so the condition of coplanarity of three lines, that has been deleted. Linear programming as a topic itself has been deleted completely. And from probability of 12th, Bernoulli trials and binomial distribution has been deleted. Okay, so that was primarily the deleted part. Now I just want to, at the beginning of my presentation, I was telling you like how to give the paper. Uh, in my humble opinion, you must always do the easy part first rather than trying to prove, because one of the things that people do is like when you go to the center, you're going to face a little hostile environment in the sense you'll see all the students like you, just like you, at the center, and you might feel a little intimidated by that the whole appearance of the center. You shouldn't feel try you should try to relax yourself. Okay, that is one thing. You should try to relax yourself. Think about all the positive things that you've done. You've prepared very well. And once you start giving the paper, try to select questions. So I remember the manner in which I used to give paper was like I would sit down and go through the questions, and my target would be like in first 1.5 hours. Now there could be many different strategies, so whatever I'm telling you right now has to be adapted by you. It has to be a very subjective thing. Okay, subject to your conditions, which topic you find easy, but you should do the easy part first. Okay, because to be very honest, every paper when it has been made, a certain guidelines are given to the examiners. Okay, so there's a blueprint they are given. They have to keep around 50 to 60% paper easy. Every session is anyways going to be normalized. So if you get a harder paper, it's going to be hard for every student in that session. If you get an easier paper, it'll be easy for every student in that session. So you should not feel elated or very let down by the level of the paper. You should therefore, keep a certain deadline in your mind. Like I would suggest 50% of the time, 1.5 hours, wherein you should have done what you find to be easy in that paper within that time. So it could be subject-based approach. If you find you're very proficient in, let's say, physics and chemistry. I am saying those two subjects because it has been a trend in the past 2 years that physics and chemistry were relatively easier as compared to maths. So if you find those two subjects to be easy, you can probably cover those two subjects in the first 1.5 hours. Usually, maybe 1.5 hour or maybe 1 hour 40 minutes or so. So usually people actually allot about an hour for physics, and many students, from my experience of teaching, I found that they were able to complete chemistry in about 30 to 40 minutes. That will leave you with about 1 hour 20 minutes or 30 minutes for mathematics. Okay. Now this is again, like I said, it's a very subjective approach. It has to be dependent upon how you have prepared a subject. Number one. Number two, actually, you see really can't predict what kind of paper you'll be getting in JEE Mains. You really can't predict. Okay, it has been a trend, but examiners are free to change that trend. Okay, so they might, for example, give let's say physics a little tougher and mathematics a little easier this time. So you should actually make a judgment independent of the trends which I'm telling you right now. You find a paper, in the paper you find physics to be tough, you can change the strategy. But normally it has been a trend that physics and chemistry has been a little easier in all of the sessions which appeared last time. So about 1 hour 20 minutes. So this has been the trend. I'm telling you the trend now. 1 hour 20 minutes to 30 minutes should be given to mathematics, because questions in mathematics require 2 3 skills. Number one, some of the questions you'll see they are a little lengthier to read in itself. So you'll have to comprehend a little of, a lot of data there. You have to make connections. There might be multiple topics involved there. So you need to connect the entire story of the question, link each part, analyze, and sometimes, maths is also a little bit of jugglery. So you need to fit things together so that actually you can, weave the entire logic of the question. So that kind of analysis you should do before you actually quit a question. Okay, you shouldn't first of all quit a question, but if you feel like that this question can be done, but it's going to take about, let's say, 2.5 minutes or 3 minutes, you should probably avoid doing so. Okay, so maybe you can prioritize it for your second, round of questions that you're going to do. Just a minute. Give me a minute, man.
I hope our students are taking down notes and all regarding the important topics and deleted portions and the strategies sir is sharing with us. Yes, sir.
Yes,
Continue,
I'm so
please.
sorry.
No
So,
problem.
like I was mentioning you, so you should actually prioritize your questions according to what you find easy. And when I say easy, it's not that I can do this question, but it'll take about 5 minutes or 3.5 minutes. That should not be your first attempt. You should first of all do those kind of questions. And you'll actually, if you do a sincere analysis, you'll see a lot of questions that can be done, let's say, within half a minute or maybe a minute or maybe 1.5 minutes. Okay. So your first attempt should be on those questions. Okay. Don't get attached too much that this is my favorite topic. Maybe I should do this, because ultimately, every question is about 4 marks only. I don't think it's more than that. So you'll not prove anything. You don't have to prove anything in the exam other than getting the marks. So it's, in that sense, it's like a video game where you just try to prioritize to complete a certain level. Okay. You have to do a question, get your marks from there, and that's it. Okay. You can prove your proficiency in that topic later. Now, I will now take some of the questions. Okay, let's analyze these questions. So these are from last year's session. There's a function f of x, which is 2x plus tan inverse x. Another function gx, log of 1 plus x squared under root of that plus x, and x belongs to 0 to 3. Then, which of the following options is or are correct? Okay, that is a question that we have here. Now, if I look at this question, what kind of skills are being involved? It's not a very lengthy question to read, number one. But at the same time, if you look at this question, you have to, so they are asking you minimum of the derivative of f of x in the first option and comparing it with 1 plus maximum of f dash of x. And then there are certain other claims also. Okay, let's look at this question. Now, f of x I'm so sorry. Yeah. Yeah. So this question, so f of x is given to us as 2x plus tan inverse of x. If I were to take derivative of this, quite an easy derivative, 2 plus 1 divided by 1 plus x squared. Okay. And what about g of x? G of x is ln of 1 plus x squared under root plus x. Okay. If you were to differentiate this, by the way, I don't know whether you people know it by name or not, because this is normally not taught in schools nowadays, but this is an inverse hyperbolic function. And you would remember it as also integral of 1 divided by under root of 1 plus x square. Okay. Probably if you remember 1 divided by under root of 1 plus x square dx, integration is exactly this function. Okay. So that way, if you remember that standard integral, you'll know because differentiation is inverse of integration inverse. So therefore, finding the derivative of this function is also quite easy. What you can automatically observe from these two is that both the derivatives are positive because they involve only even power of x. Okay, you should be quite observant in comparing these two. Okay, ma'am. Is the PPT shared?
No, sir.
Yeah.
Yeah, we can see now.
Yes, ma'am. I think whatever I wrote. Okay. F dash of x is equal to 2 plus 1 upon 1 plus x square. And if you differentiate it again, you'll get minus 2x divided by 1 plus x square whole square. So if you have to see, f double dash of x is negative, wherein f dash x is positive. Okay. What does it tell us? The derivative, second order derivative is telling us something about the first order derivative. That first order derivative is a decreasing function. A quick observation there. And what does this tell us? This tells us f of x is an increasing function. Okay. If you look at g of x is ln 1 plus x square under root of that plus x. The derivative we had already seen was 1 divided by 1 plus x square to the power half. And if you were to differentiate, so this is again positive, we saw that. That tells us g is also an increasing function. But if you differentiate it, what would you get? You'll get minus half into 2x divided by 1 plus x squared to the power 3 by 2. Okay. And since you've been given the interval 0 say to 3, wherein you also have to pay attention to that x belongs to this interval. So x is a positive number. Therefore, this is also negative. What does it tell you? That both the functions are increasing and their derivative is a decreasing function. Now, if you look at the data of this question, or rather the options of this questions, they're asking you what is the minimum value of f dash. Okay, one of the things that you have to evaluate is the minimum value of f of x. Minimum, because f dash x is decreasing, minimum value of f dash will be obtained at the right point, okay, of this interval, that is 1, that is 3. Okay, this was closed interval 0 to 3. So you can put the value in the expression and see 2 divided by 1 plus 3 square. Okay, that is 2 plus 1 by 10. Okay, and if I look at what was on the right hand side, it was 1 plus g dash of x. Okay, so they're saying minimum value of f dash is same as 1 plus maximum 1, I think. Okay. This is some problem here. It is board. So 1 plus G dash X max. Okay. That is what they're saying. So if you look at this value, G dash, you have the expression. And if you put 3 over there, 1 plus root 10 will appear. So they are not equal. So first option is wrong, obviously. They exist two values x1, x2 belonging to 3 such that f of x is less than g of x for all x belonging to x1 to x2. The third option says there exists x belongs to 0 to 3 such that f dash x is lesser than g dash of x. And the fourth option says maximum value of f of x. Of course, the easiest to involve, to easiest options to actually, opt out here are the first and the fourth. Okay, so once you're looking at the question, if you look at what options you should evaluate first, first and fourth options are very direct because you've already differentiated, the trend of f of x and g of x. You evaluate the first option, obviously it turned out to be wrong. Now you should evaluate your fourth option first, okay? Because other things are actually asking you to evaluate, or they're claiming certain values of x exist or not. If you look at the fourth option, it's saying maximum value of f of x. Can we find maximum value of x? Of course we can, because we know, we have always shown f of x will be, its derivative is positive, so f of x is an increasing function. So we can find increasing, since it's an increasing function, we can find maximum value of f of x as f of 3 and maximum value of g of x. Sorry. That can also be validated. Okay. And then you can compare them. Okay. I'll go to the next question. Let R be a relation on the set of real numbers given by set of ordered pairs A, B such that 3A minus 3B plus root 7 is an irrational number. Okay. Then R is which of the following? Is it reflexive? Is it symmetric? Is it transitive? Or is it an equivalence relation? Of course, equivalence relation is a relation wherein it is all three. Okay. So this kind of question is not where, how should you attempt this kind of question? Should you go out of for proof because, or should you produce a counter example or an example? Because if it is reflexive means that if A is related to B, then B should be related to A. So if 3A minus 3B plus root 7 is a rational number, of course, so reflexive means that was what I talked about was symmetric. So reflexive is when A is related to A. So if A is related to A, that means 3A minus 3A will get cancelled and you'll get root 7, which is an irrational number. But is it necessarily symmetric? So symmetric means if A is related to B, then B is also related to A. That can be shown wrong using counter example. So when I say counter example, I mean to say that you show that there exists certain pair of A and B where this does not really hold true. Okay. So can you show some example like this? क्या आप लोग आंसर कर सकते हैं बच्चे लोगों? Can you answer? Are they connected, ma'am? Can they speak?
Yeah.
Can you produce a counter example here? Since the kind of skill required to solve this question has changed actually. Okay. You need to produce a counter example. Anyone?
Students,
Any students?
switch on their videos, please. We would like all of you to switch on your videos and also be a little more participative. You can also put your answers in the chat box. Anyone?
Anyone from Bhopal? I think Bhopal region joined quite early. Raipur? JNV Raipur. So if I were to take, let's say, B as a number which had minus 7 root 7 by 3 as a certain part of it. Okay, so let's say if I have B as A, or let's say some constant K minus 7 root 7 by 3. Okay, K could be any number that you, or rather, let's say integer. Okay, where K is an integer. Okay, and A as, let's say, another integer, L. Of course, if you were to put them here, 3L minus 3K minus root 7 by 3, okay, plus root 7. So what you can see is I'll get 3 into L minus K, and then plus root 7 plus root 7, that means 2 root 7. So of course, if these two are integers, this is an irrational number, the sum is an irrational number. But this means that I've shown that A is related to B. For it to be non-symmetric or asymmetric, I have to now show that B is also is not related to it. So if I interchange the position of A and B, I'll get 3 into K minus root 7 upon 3 minus 3B plus root 7. Okay, and here you can see that the irrational part will get cancelled, and you'll get 3K minus, this was L, so minus L, which is an integer. So it's no longer an irrational number. So we can see that is not symmetric. Okay. Now, once you have shown that, you are left with two options. It is not symmetric. So you have to produce a third counterexample or the second counterexample to show that is non-transitive. Okay. I think this is one of the approach that you have to keep in mind. Okay. Producing counterexamples, especially when questions related to equivalence or like relations, like this appear. Okay. I'll go to the next question. This is again what I call as rearrangement. Okay, integration especially, and in other questions also, one of the tricks which really helps is to rearrange things. Okay, it looks like a very big integral, a very disruptive integral, but I just ask you people, what exactly would you do when you look at this integral? Okay, what are the tricks that we use to integrate? Of course, when you're looking at a definite integral, we look at the properties of definite integral, right? So there's the property f a plus b minus x, right? F of a plus b minus x, integral a to b is same as integral of a to b. Then there are other properties also like 0 to 2a f or periodic functions and so on and so forth. But integration, when you're considering, there are a lot of tricks. So you have integration by parts also, and then you have substitution also. Okay. So what would you do in this question? It looks big, huge. Probably you might feel like it's not, it's going to take a lot of time also. What do you think you should do here? Is there any substitution that we can do? So when they are polynomials, so this is a kind of trick which examiners like a lot. When they're polynomials, you must look at the data very, very carefully, especially the coefficients. Look at the coefficient here, 2, 3, and 6. Okay. These coefficients are your biggest hint. Okay. And then the second hint is this power. Okay. And then 1 by 7. So if you can see, the third hint is that you may choose whatever amount of x that you want, or some amount of x common here. Now, of course, the least power here is 7. So you may take x to the power 7 common from this. Okay. Or rather, x cubed to the power 6, any power, in fact, between 1 to 6 common out of this. So let's take 1x common. So that will reduce power by 1 in the first bracket. So this will become, I think, 13. My fault. Okay. So the first power reduces, it becomes x to the power 20, and then you'll get x to the power 13, and x to the power 6 here. And the second bracket, what you do is you send it in. So there is an exchange of terms happening here. Okay. So once this x goes inside that power 1 by 7, it will become x to the power 7. Okay. So we can, remove it here, put it there, x to the power 7 to the power 1 by 7. Okay. And therefore, once it gets multiplied, you'll get 21 here, you'll get 14 here, and then 6x to the power 7 here, right? Isn't it? Isn't it, guys? Anything that you can do now? Does it help us? How does it help us? Can anyone tell me? How does rearranging like that help us? That helps us because now we can make a certain substitution. Okay. So now you can make a certain substitution. What kind of substitution am I talking about? If you look at it, 2 into 21 is 42. And what is 3 into 41? 14, sorry. Isn't that also 42? Which is also 6 into 7. So there is certain amount of homogeneity that has been ensured. So if you were to take this expression, or rather this expression as some t to the power 7, 2x to the power 21 plus 3x to the power 14 plus 6x to the power 7 as t, you can see once you differentiate it, you will get 42 outside, and then you'll get the same expression x to the power 20 because power will reduce plus x to the power 13 plus x to the power 6 into dx as dt. Okay, so this expression will be removed and you can replace this by dt by 42. Okay, or at the same time, if you want to remove this irrationality, you can choose this as t to the power 7. So you'll get 7 into t to the power 6. And then after that, I think the integration becomes very easy. Okay, so all you need to do is do a little bit of rearrangement in the question. Okay, so try to look at the data very, very carefully. Numbers are set according to certain pattern. Let's look at another question. Locus of midpoint. Locus is again one of the Achilles heel. We find it very difficult. It's a topic which disturbs a lot. So locus of the midpoint of the chords of the circle which subtend an angle theta I at the center of the circle is a circle of radius Ri. Okay, circle is actually Ci. So there's a family of circles that they're talking about, and it is a circle of radius Ri. So if I look at it, we have already a given circle. Now, in this kind of question, you can see the language is really lengthy. Okay. And therefore, normally what? So you should draw a diagram first. Okay. Supplement any question on geometry by a diagram. Let's say this is a circle. Center, of course, we can see as 4, 5. Let me just write it over here. O, let's call it center as O. This is your circle Ci. Locus of midpoint of the chords of the circle, its radius is 2. Okay. With subtend an angle theta I at the center of the circle C1. So there is another family of circles. We want locus of midpoint of its chords. These chords are subtending an angle theta I at the center of C1. Okay, so these endpoints, when you join them, they're subtending an angle theta I. Is that clear to everyone? So locus of midpoint of the, so do we know the equation of the midpoint, the chord whose midpoint is given? These are subtending an angle theta I at the center of this circle. How do you approach this question? There are two angles which are given to you, theta 1 and theta 2, theta 3. And they're asking you for theta 2. Okay, so this is not one circle. This is, even though I've drawn one circle, there are many such circles. They're subtending a certain angle at a fixed point. Okay. So if you see, C1 is not required as such. You can actually choose one circle and say there's another point somewhere, 4 comma 5, and all these points, these chords are subtending a certain angle at that point. Okay, so let me just choose that point over here. Okay, so they're subtending a certain angle at this point. How do you approach this question? Yes? Anyone? Yes, students?
Teachers, please encourage students to unmute and come and talk. You can interact with sir. Any students, teachers?
Any teacher can also answer. How will you approach this question? Yes? Anyone? I would really love you to answer this question.
Teachers, please. The session was meant to be interactive. No idea, sir. Normally, our teachers and students are really interactive. We have to
Okay, no
control them
problem.
like time is up like that. Today, I don't know
Yeah,
what's
I think
happening.
time is a little on the higher side, so that's okay. Like I said, better choose your questions, ma'am. I'd like to end this session also because I think chemistry session is lined up at 4 o'clock, right?
Yeah.
Yeah. So choose your questions very nicely. Select and try to spend your time judiciously. Like physics and chemistry, like that is a very solid device. Try to complete them as soon as possible, and then keep a little, because the trend has been maths is a little lengthy. Okay. Thank you, ma'am.
Thank you so much, sir.
Sure, ma'am.
As-
Thank you.
mm, So I think even the teachers and students, even if they are not interacting, I guess they are taking down notes. And this session was really helpful, just to
Thank you.
like in order to filter out which is the topic on which we have to give more weightage and how to attempt like physics or chemistry or mathematics, and even sharing like shedding light on the deleted portions. So
Ji.
thank you so much, sir, for this
Thank you, ma'am.
wonderful session.
Ji.
And wishing you all the best in your future endeavors. Thank you
Thank
so
you,
much.
ma'am. Thank you.
Thank you, teachers and students.
Thank you, Abhishek sir, for joining. Everyone, please stay tuned. We will be beginning the next session very soon. We will take a quick 5 minutes break till the time we have. You can grab a glass of water and take a breather. And we'll start the next session at exactly 4:10 as it was scheduled in the poster shared.